Welcome to my dear students and learners. So today I am going to discuss one aspect called analog multiplexing. Here some assumptions or prerequisites are there that I will elaborate. Just I am showing you the technique. Why it is needed, I will tell you the background also, because always I used to share my experience. Some few weeks back, I was dealing with one food processing industries, and there will be some upgradation in the food processing techniques. So definitely number of sensors are to be added, but the existing controller having some limitations of IOs. Normally, whenever the analog IOs are concerned, naturally it should be less. Normally in a controller, or if you take the example of a PLC, so their digital IO will be more, say 32 channel, 16 channel or 64 channels. But compared to that, the ADC will be very less. That will be a 4 channel or 8 channel. It will be like that. So similarly, the existing controller of the food processing industry having some 3-4 IOs left out. So there we have to accommodate several, because in food processing, temperature control and the pressure control, the vacuum control, it is the major aspect. So there this number of sensors are more. They want to increase it. Okay, so there is a concept called analog multiplexing the implementation of the same was evolved, and I am going to explain that. So here the main prerequisite is that the sensing of the process parameter is very slow. Okay, and you need not to do that things is in very high rate, sampling rate, or all the data need not to be captured in same time stamping. So in such case, definitely this multiplexing technique is not sufficient enough, because in a single channel more number of sensors are to be added. So for this particular example, I will be showing you 4 sensors data. Say take this is the sensor 1, this is sensor 2, this is sensor 3, this is sensor 4, and this 4 data, the 4 say it is thermocouple or RTD. These signals are to be captured. These signals are to be captured in a controller using a single ADC. So what I will do in between I will put some switches, and through that switch it will be connected to a particular channel of the ADC. It's a single channel. Okay, this will be a single channel. So you see the connection how I am doing. So it is like that, and definitely here in between some signal conditioning modules are there, because in case of thermocouple this output will be millivolt, but this controller definitely it will in ADC, in controller ADC, definitely it will be the reference voltage will be either 0 to 5 volt or minus 5 to plus 5 volt or 0 to 10 volt, like that. So this signal conditioning module, it is converting this millivolt output to volt, which can be easily read by this ADC based on its resolution. And to select this particular means, first this switch will be closed. So the concept is, the first this switch will be closed. This is switch 1, switch 2, switch 3, switch 4. So first the switch 1 will be closed and the data will be reaching to that particular ADC, and once the conversion is over, then this data will be read, and once the reading is over, then this switch 1 will be closed and switch 2 will 1 will be open and switch 2 will be closed, and that time sensor 2 data will be read, and so on. This cycle will be proceeding. So how much time I should close the switch? Say the ADC conversion time ADC conversion time is T conversion, T-con. Then how long this switch 1 should be closed? That should be at least greater than, this T1 should be greater than the conversion time of the ADC. Okay, so here you see this will be all the data will be read serially. So in case of force sensor, what should be the sampling time of the data logging? That will be at least 4 T-con. Say if the conversion time of the ADC is 50 millisecond, so the data will be logged or data will be monitored after every 200 millisecond. So these are the limitations. This is the limitation. Means it will be slow because serially we are reading. Okay. So now here one more controller should be there, which will be providing the selection bit. So this is the control pulse for switch 4. This is the control pulse for switch 3. This will be control pulse for switch 2, and this will be the control pulse for switch 1. and the same pulses will be taken to one normal GPIO of the PLC of the controller. Means whenever this switches, and what should be the timing diagram? So the timing diagram will be, so this is the timing diagram for the switch 1, and this duration should be at least equal to the conversion time of that ADC. Then what should be the second one? Once the conversion is over, give some delay, then give a pulse to switch 2. Okay, and for switch 3 it is like this. So you are using a pause for safer side, so this should be a pause. And once the conversion is over, then the selection bit is going to high to low, so there will be a falling edge detection. Means you will get a falling edge, and once the falling edge detected, then at that particular time you read that ADC value, that will be giving that particular channel value. So this is basically the conception. So let us see it by, because here I don't have the PLC simulator, so I have microcontroller. So using that I will be explaining the technique. So here this controller is generating, this controller is generating the selection bit, and the switch, whatever I mentioned earlier, that is used that switch is used as an optocoupler. So once that selection bit is high, then this optocoupler is on, and this potentiometer value, it is going to the particular channel of the ADC A1. You see, in the second controller I am using only one channel, and this selection bit I have taken as an input to the controller. So once that selection bit is high, then that particular switch is high, and this potentiometer value is going to that analog channel. It is reading, because it will be, that selection bit will be high. Okay, so here that switches, whatever the switch I have mentioned, that is used as this optocoupler. So whenever this selection bit is high, that time this optocoupler is getting closed, and this particular potentiometer value is going to that channel. And once the conversion is completed, that means it will be confirmed by the falling edge, because after that, that particular switch will go off, and the next switch will be the analog value through the next switch will be transferred to ADC. So in this way it will be done. So this first controller, it will be providing the selection bit, and this second controller, it will be reading the ADC. The ADC will be so let us now see the program. Okay, so here you see this, here one variable I have defined, which is giving the on time, which is where the on time of the selection bit is defined, and initially all the selection bits are initialized as low. Then after that, the first selection bit I am making high, then it will be holding for that particular time, which is at least equal to the conversion time of the ADC. Then I am making again all the selection bit to 0. I am giving a safer pause to that, okay, so that the switch is completely get off. So in practical case, that should be at least greater than the off time of the switch. Then I am making the second selection bit as high, and it is going so on. So this is the code for the selection bit. Now I am coming to the how the ADC is getting read. So as I am going to read the falling edge, so to read the falling edge, and I am using the normal digital input to read that falling edge. Normally it can be done through the interrupt pin in case of microcontroller, but the interrupt pin of the microcontrollers are limited, and it is a very slow process, so you need not to use that interrupt. So you can use normal GPIO pin. So for that, as there are 4 selection bits, so this PS means I mean to say it is a previous state, and CS means it's a current state. So that is defined here, initialized as 0. So what I am doing, first I am reading all the current state by reading the status of all this selection bit, okay, and when this toggling it will be taking place, means the falling edge will be there, then the current state and the previous state will be not the same, because it will transit the transition will be taking place from high to low, and finally it will be, once the transition is complete, it will be low. So once there is a change of state, then it will enter inside the loop, and once it is become low, then this condition will satisfy and it will print the ADC value by reading the channel. And once it is permanently become low, then this condition will be not satisfied because the present and past state are same, so it will come out from the loop. And this is for the second channel. This is for the third channel. And lastly, the previous state should be the current state, because then only it will be that infinite loop, it will be running. So this is the very simple code for that. Okay, this is a very simple code. So now let us see the simulation. Okay, so here in this controller, this selection bit is updated, and here the ADC value is getting read, and it will be captured at each falling edge of the selection bit. So now I am running it. Now you see the reading process is quite slow, but here I am using only one channel. So let us change the value of the first sensor. You see I am reducing, so it is 630, now it is 365, so it is changing. So now let us change the value of the second channel. It is 1008. So if I reduce, you see it has come to 814. The channel 3, so this is the channel 3. So if channel 3 value is 548, so if I increase it, you see it is getting increased. Okay, it is getting increased. Now the channel 4, so this is the channel 4. If I reduce it, at present it is 661, so I am reducing. So you see it is happening like this. So this is a simple technique I have explained. It's a analog multiplexing, even though it's a slow process, but using a single channel, you can read multiple data by adopting this technique. Only the limitation is it is depend on the entire sampling frequency. It is depend on the conversion time of the ADC and how many channels you are using. That many times, after that many times only, the data will be logged or monitored. So this is the concept. I hope you have understood it. Thank you so much. Thanks for your patience.